this video, we're talking about how to solve fractional equations and abstract fractional equations. So in this first example here, we've been asked to solve for x, and we have the equation 4x plus 2 over 5 minus 3 halves equals 1/3. Notice that we just have a single variable x here that we need to solve for. This is just a simple fractional equation. We start getting into abstract fractional equations when we have more than one variable involved, as we do over here where we have both x and a involved. So we'll talk about what the differences are between just fractional equations and abstract fractional equations. But doing this first example here to review a little bit, what you want to do when you have a fractional equation, meaning an equation with fractions involved, is you want to look at all of your denominators and find a common denominator. So in this equation, we have denominators of 5, 2, and 3. So we're going to be looking for a whole number common denominator that's the least common multiple of 5, 2, and 3. So remember that when we want to find the least common multiple of whole numbers like this, we look at the largest number. In this case, that's 5. 5 is larger than 2 and 3. So we look at the largest number, and then we look at its multiples, and we want to find the multiple that 5, 2, and 3 all go into evenly. So 5 times 1 is 5. Neither 2 nor 3 go into 5 evenly, so that's not going to work. 5 times 2 is 10. 2 goes into 10 evenly, but 3 does not. 5 times 3 is 15. 3 goes into 15 evenly, but 2 does not. 5 times 4, 20 won't work for 3, 25 won't work for 3, 30, 2 goes into 30 evenly, and 3 goes into 30 evenly. So 30 is going to be the least common multiple of 5, 2, and 3, and therefore it's going to be our common denominator. So once we've identified that common denominator, we want to multiply every term on both sides of the equation by that number. So in this case, it's 30. And now we're just looking at distributive property here. We want to distribute the 30 across each term on the left-hand side and the right-hand side. So 30 times 4x plus 2 over 5. Well, with 30 in the numerator and 5 in the denominator, we can reduce that fraction to 6 over 1, right? 30 divided by 5 is 6. So really, we're just multiplying the numerator by 6. So we get 6 times 4x plus 2. Multiplying 30 by negative 3 over 2, well, again, we have 30 in the numerator and 2 in the denominator, so that's like 15 over 1, so we're really just multiplying the numerator by 15. So we get minus 15 times 3. And then here, 30 times 1 over 3, we have 30 in the numerator and 3 in the denominator, so that's like 10 over 1. That's like multiplying the numerator by 10, so we get 10 times 1. And now we just distribute, so 6 times 4x plus 2 gives us 24x plus 12, 15 times 3, negative 45, and 10 times 1 is 10. Now we'll subtract 12 and add 45 to both sides, minus 12 plus 45. That'll give us a positive 12 and a negative 12 canceling, and a negative 45 and a positive 45 canceling, leaving us with 24x on the left. On the right, 10 plus 45 is 55. 55 minus 12 is 43, so we get 43. Dividing both sides by 24 lets us cancel the 24 in the numerator and denominator on the left, leaving us with just x is equal to 43 over 24. So that's kind of a review of basic fractional equations. What happens when we start throwing in another variable? Well, in fact, it actually doesn't change anything. We call this an abstract fractional equation because we've got multiple variables, but we're still doing the same thing. We're still looking at all of the denominators of our fractions. In this case, we have two fractions. The denominators are x and x plus a, so we still need to find a common denominator between those two. Well, the common denominator between x and x plus a is just x times the quantity x plus a. So we get x times the quantity x plus a. That's the least common multiple, or the lowest common denominator between x and x plus a. So we have to multiply that denominator by every term on the left and right hand side of our equation. So when we multiply this denominator by 4 over x, the x's will cancel. This x here in the denominator will cancel with this x that's now in the numerator, leaving us with just 4 times x plus a. When we multiply x times quantity x plus a by 6 over x plus a, the x plus a in the denominator will cancel with this x plus a that's now in the numerator, and we'll just get 6 times x, or 6x. Then when we multiply x times quantity x plus a by 1, we just get, of course, x times x plus a. Now we want to simplify everything by distributing 4 across x plus a, so we'll get 4x plus 4a, leaving the 6x, and then over on the right, x times quantity x plus a is going to give us x squared plus ax when we distribute the x across the quantity x plus a. Now keep in mind here that we've been asked to solve for the variable a, which means that we need to get all the terms that involve a by themselves on one side of the equation. So the only terms involving a are this positive 4a here and the positive ax over here. So what we want to do is subtract ax from both sides. On the left, that'll give us 4a minus ax. When we take those two terms, we'll get positive ax and negative ax to cancel. We want these by themselves, so we also want to subtract 4x, subtracting 4x, and we want to subtract 6x, so minus 6x and minus 6x. That'll give us positive 4x, negative 4x, positive 6x and negative 6x canceling on the left, so we're just left with 4a minus ax on the left-hand side, and on the right we have x squared right here, and then a negative 4x and a negative 6x is a negative 10x. Now that we have the terms involving a isolated by themselves on one side, we factor out the a, so we factor out an a from 4a and negative ax, and we get a times 4 minus x is equal to x squared minus 10x. And now with a factored out by itself, we can divide both sides of the equation by whatever a is multiplied by, in this case 4 minus x, so 4 minus x, because that'll cancel the 4 minus x on the left-hand side, leaving us with just a. So then our answer will just be a is equal to x squared minus 10x, all divided by 4 minus x.